Hello everyone. If you are from finance background, commerce, economics, MBA, banking and finance and you keep hearing words like quant, data science, risk model, machine learning and now generative artificial intelligence, this video is for you. Today I am going to give you a full job focused foundation that a fresher can actually use. Not theory for exams, not just formulas, and definitely not a random list of buzzwords. We'll build a logical picture of how multinational corporations expect you to think in 2026 when you work in finance plus analytics. And I'm going to do it using simple idea. A company doesn't hire you for models, they hire you for decisions. Models are not just one tool to help decisions. So throughout this video, I'll keep bringing you back to the same question. If I give you a finance problem and data, can you turn it into a clean decision process and explain it clearly? If you can do that, you become employable. Before we start, one small disclaimer. This is educational content, not an investment advice. Now, I want you to do one thing to make this video truly valuable. Open Notes app or take a paper and write this line. My job is to translate finance problem into data, model and decisions. Because that is the job, whether you title say analyst, quant, data scientist or risk modeler. What quant finance plus data science actually means in real jobs. Let's remove the confusion first. Quant finance is a short form for quantitative finance, which means using mathematics, probability, statistics, and programming to solve finance problems like pricing, risk, portfolio decisions, trading analytics, and many related areas. Data science means extracting insights and building models from data, structured and unstructured data, and communicating results so a business can act. In 2026, the overlap is huge. Finance teams don't just analyze, they build models, monitor models, and defend models and update those models. This is not my opinion. This is the literally how modern job definition describe these roles. For example, official occupational descriptions for data scientists emphasizes transforming raw data into meaningful information, applying data mining, data modeling, NLP and machine learning, then visualizing and reporting findings. And for financial quantitative analysts, the work includes applying mathematical or statistical techniques to practical finance issues like derivative valuation, securities trading, risk management, regulation, developing pricing models, building model libraries, documenting requirements, producing written reports, maintaining models in use, and even verifying results of analytic systems independently. Now, notice something important. It is not only build a model, it's also document it, validate it, maintain it, explain it, and verify it. That is exactly the MNC mindset. Now you might be thinking, but I am a fresher, how can I match that? Here's the answer. You don't have to master everything, but you must show that the right shape of skill. In 2026, a large global employer survey published in early 2025 covering 1,000 employers representing more than 14 million workers highlights that technology, economic uncertainty, demographics, and green transitions are reshaping skills and jobs through 2030. That report's headlines numbers are famous for a reason. It describes massive job churn with millions of roles created and displaced, and a big emphasis on upscaling. So, the hiring logic in MNCs has become we want people who can learn fast, work with data responsibly, and build models that survive reality. Now, let's make this practical with a simple storyline. A realistic fresher storyline, what you will actually do in your first job. Imagine you join an MNC finance analytics team. Your manager gives you three tasks over your first few months. First, risk scoring. Predict which customers are likely to default. That's a classification problem. Task 2, forecasting. Estimate next month's risk exposure or volatility. That's a time series problem. Task 3, document intelligence. Make sense of a large number of policy documents, product notes, or reports and answer questions quickly. That's a modern generative artificial intelligence and information retrieval problem, but only if done safely. Now, here is the key. If you can solve these three tasks at a basic level with correct validation, clear explanation, and good documentation, you can crack fresher roles. So in this video, we will build the foundation you need to solve these tasks with Python and optionally scale in notebook environment like Databricks notebooks when data is very large. And I'll keep asking you retention questions so you don't just listen, you actually learn. Now, the MNC workflows, the 8-step loop that matters more than any algorithm. Most freshers fail because they learn models without learning the workflow. So here's the workflow that MNCs actually follow. I want you to memorize this. First, define the decision. Second, define the target. Then understand the data generating process. Build a baseline around it. And then start creating a model around that particular baselines. After that, evaluate with the right validation. Then explain with document and then monitor and improve. Let's quickly unpack each one of these in a practical tone. First, define the decision. Not a predict default, that's not a decision. A decision is, should we approve this loan? Should we lower the limit? Should we flag for review? A model is only useful if changes a real action. Then define a target. Target means what you want to predict. In credit risk, default in the next 90 days, yes or no. In trading analytics, next day volatility, a number. In fraud, suspicious transaction, yes or no. But here's the real world twist. Targets in finance are messy. Sometimes a default is not recorded consistently. Sometimes a fraud case is delayed. Sometimes outcome change because business rules change. So you must ask, how is this target created? Then understand the data generating process. This is where finance background helps. Ask, where does this data come from? From transactions, from customer forms, from market feeds, from accounting systems. If you don't understand the process, your model becomes a magic trick that breaks. Then build a baseline. A baseline is a simple method that works even without a fancy modeling. For example, predict everyone as a non-default. Baseline accuracy might look high if defaults are rare. Predict using last month's average. Baseline forecasting. Baseline protect you from building a complicated model that adds no value. Then build a model. Now you use statistics and machine learning here, but model selection is not the real skill. The real skill is building something robust. Now evaluate the right validation. In finance, if evaluate incorrectly, you are basically cheating without realizing it. So evaluation is everything. Explain and then document. MNCs love people who can explain it clearly. If you can't explain your model, the business won't trust it and the risk team won't approve it. Now, a model is not a one-time project. Market changes, customer behavior changes, and fraud pattern changes. So if you monitor drift and performance. Now here's the retention question. If you build a model that performs well once, but you cannot explain it and cannot monitor it, is it production ready? Ask yourself, no, in MNC's environment, that's not acceptable. That is why, especially in financial services, regulators and risk teams focus heavily on model governance and life cycle management. Not just performance. Will come to that. Now we need foundation, data basics first. Data foundation for finance freshers, the things companies quietly test. Let me say something clearly. A fresher who is strong in data handling is often more valuable than a fresher who knows 10 machine learning algorithms, because companies can teach you algorithms, but they hate cleaning your messy work. So here are the data foundations you need. First, structured data versus unstructured data. Structured data is a tables, transactions, customer profiles, price series. Unstructured data is documents, emails, call transcripts, notes. In 2026, both matter, but as a fresher, you should start with structured data, then add unstructured basics. Granularity, the most common finance mistakes. Granularity means the level of detail. Example, customer level table, one row per customers. Transaction level table, many rows per customers. Daily market data, one row per day per instrument. If you mix granularity wrongly, you create wrong features. A classic mistake here is you take a transaction table, compute total spend and join it back to customers, but you accidentally include future transactions after the date you are predicting. This is called data leakage, using information that would not be available at prediction time. Leakage is the number one reason great models fail in real life. Time matters. Event time versus observation time. In finance, time is not just a column. You have to think what did we know at the moment of decision. This is sometimes called point in time correctness. Example, if you are predicting default on January 1st, you can use the customer's income as of January 1st, not the income updated in March. This is why MNCs ask, how did you avoid leakage? Now, missing values not just filled with mean. In finance, missing can mean different things: not applicable, not reported, system error, customer refused to share, new customer with no history. If you blindly fill with mean, you may erase meaningful signals. A practical approach here is ask why it is missing. Create a missing indicator feature. Choose a fill strategy that makes sense. Outliers, not always errors. In finance, outliers might be a fraud, rare events, or real high value clients. So instead of removing outliers by default, identify them, check if they represent errors, or cap them carefully. A small Python mindset shift: when you work in Python, don't think I need to run this code, think I need to build a reproducible pipeline. Meaning, same raw data, same cleaning steps, same feature creation, and same results every time. This is the difference between student work and industry work. And if your data set is large, millions of rows, team often use scalable notebook environments like Databricks notebooks. So your Python workflows can handle big data with distributed computing. But the mindset is the same: clean pipeline, reproducible steps, and correct time logic. Now, with data foundations done, we move to the finance math that actually matters. Finance math, you must know returns, compounding, and why log returns exist. Let's start with the simple: what is return? If price goes from 100 to 105, the simple return is calculated like 105 minus 100 divided by 100 is 0.05, means 5%. Now, why does finance sometimes use log returns? Log returns equals to log of 105 divided by 100. The reason is log returns add nicely over time. If you have log returns for each day and you sum them, you get the total log return for the period. That makes modeling and aggregation easier. Now, here is an interview style question: why do we care about compounding? Because in finance, growth multiplies. If you gain 10% and then lose 10%, you are not back to zero. You are at zero point 0.9 into 1.1 means 0.99, which is a 1% less. That's why risk metrics often use concepts like drawdown, not just average return. Now, volatility, the most used risk concept. Volatility is basically the standard deviation of returns. Standard deviation is a measure of spread. If a stock has a return that jump around, it has a high volatility. Now, let's talk about annualization. I will take this quickly. So these are the basic keywords that are used regularly in finance. So annualization and the hidden assumptions. People annualize returns and volatility. Return annualization assumes compounding. Volatility annualization often assumes independence and scaling with the square root of time. This is where you should be careful. Finance returns are not perfectly independent and not perfectly normal. That's why risk modeling becomes important. Now, again, the retention question. If two assets have the same average return, what makes one riskier? To answer that, higher volatility, worse drawdowns, and heavier tails, more extreme losses. And that brings us to the probability and statistics. Probability and statistics, the real language of quant work. If you want to survive quant and data science interviews, you need to speak probability and statistics comfortably, not like a textbook, like a decision maker. First, let's go to few keywords like first, random variables. The simplest definition: a random variable is a quantity with uncertainty. Daily return is a random variable. Default event is a random variable. Now, what is distribution? Distribution, the shape of uncertainty. A distribution describes how outcomes are spread. In textbooks, people often use the normal distribution. In real finance, results often show heavy tails. Extreme events happen more often than a normal distribution would predict. So in practice, you must always ask, is my distribution assumption reasonable? Then expected value, average outcome. Expected value is a long run average, but in finance, the expected value alone is not enough. Two strategies can have the same expected value, but one can blow up due to the rare events. Now, What is variance and standard deviation? Variance measures spread, standard deviation is the square root of variance. In finance, standard deviation is often interpreted as volatility. Covariance and correlation. Correlation is normalized covariance. Correlation matters in portfolios. If assets are not perfectly correlated, diversification reduces risk, but in crisis periods, correlation can increase. So, in portfolio risk, correlation is useful but not a guarantee. Now, here's the practical mini example. Imagine there are two stocks, stock A, stock B. Stock A, stable consumer business, stock B, high growth speculative business. During normal times, they might not move together much, but during panic, both may fall together. So, correlation is dynamic. Now we move to the most powerful idea of the jobs that is statistical inference. Statistical inference, is this real or is this luck? MNC interviews often test whether you can understand this. Data is noisy, results can happen by chance. So you must show you can measure uncertainty. Sampling variability. If you estimate average return using 20 days, your estimate is unstable. With 1000 days more stable. This is why sample size matters. Confidence interval. A confidence interval gives a range of parameter. For example, your estimate average return is 0.5% per day. Plus or minus some range. In finance, confidence intervals help you to avoid false certainty. Now, hypothesis testing. This is where many trading strategies die. You test null hypothesis, means no edge. Alternative hypothesis means there is some edge. But here's the big trap. If you test 100 ideas, one will look good by luck. That is called multiple testing. So in finance, you must adjust your thinking, not just statistical significance, also economic significance and robustness. Effect size, the business side of statistics. Let's say a model improves a metric slightly, but does it change profits or reduce losses meaningfully? MNCs care about impact. So in interviews, learn to say, even if it's statistically significant, I checked if it's practically meaningful. That sounds mature. Now I'll give you a retention mini quiz. If your backtest show profits, what are the first three questions you should ask? Here are the strong answers. Did I accidentally use future information? What happens after transaction costs and slippage? Did I overfit by trying too many parameters or strategies? Now we are ready to talk modeling, statistic modeling that is actually used. Let's talk about statistic modeling. The models that build careers for finance freshers. Let's be honest, you can get 80% of fresher finance analytics roles by mastering three model families: regression, classification, and time series forecasting. And for each one, the real skill is not running Python code. It's selecting the right features, validating correctly, and explaining clearly. We'll start with regression. Regression, the simplest model that appears everywhere. Regression predicts a number. Examples in finance: predict volatility, predicts demands for a product, predict next month's revenue, predict yield changes with caution. It Linear regression is a part of regression. Linear regression assumes a relationship like target equals to intercepts plus coefficient into features plus noise. In practical terms, if a feature changes by 1 unit, how does the target changes on an average? A finance style example would be: you want to understand how a stock reacts to the market. Your target is a stock return. Your feature is market return. Your coefficient is sensitivity. This idea appears everywhere even if you never call it a specific named theory. What MNCs test in regression interviews, they do not test if you can fit the model. They ask, can you interpret coefficients? Did you understand assumptions? Do you handle outliers? Do you detect leakage? Can you explain residuals? Let's make assumptions practical. First assumption, linearity. If the real relationship is non-linear, a linear model may be wrong, but sometimes linear models still work as a good approximation. Assumption 2, independence of errors. If errors are correlated over time, your estimates may be misleading. This matters in time series. Assumption 3, constant variance. That's called homoscedasticity. If variances changes with the level of target, very common in finance, the standard errors and confidence intervals can be wrong. This is called heteroscedasticity. You don't need to sound fancy in interviews. You can say the spread of errors increases for high values. So I checked stability. Now assumption 4, which is multicollinearity. If features are strongly correlated, coefficients can become unstable. For example, income and spending might be correlated. If both are in the model, coefficient might flip signs. That's not always wrong, but it affects interpretation. Now, here's the practical takeaway for freshers. Regression is not only prediction, it's explanation. If you want shortlisted in MNC, being able to explain is powerful. Now we move to the classification, which is huge in any of the finance jobs. Classification, which is credit risk, fraud, churn, and compliance. Classification predict categories. In finance, the most common classification outputs are default versus non-default, fraud versus non-fraud, suspicious versus normal, high risk versus low risk. And here, logistic regression, the finance industry's workhorse. Logistic regression predicts probability. Probability of an event functions of weighted features. This is widely used because it is interpretable, stable, easy to validate, and easier to defend to risk teams. The biggest fresher mistake here is using accuracy. Accuracy can be a misleading when classes are imbalanced. Example, if only 2% of customer default, predicting no default for everyone gives 98% accuracy, but the model is useless. So in finance, you look at precision, recall, receiver operating characteristics, which is ROC, care curve and area under the curve, AUC, ROC, AUC, which is short form, calibration, cost based evaluation. Let me define this clearly. Precision, out of predicted positives, how many are the correct? Recall, out of actual positives, how many did you catch? In fraud detection, missing fraud is expensive. How low recall is bad. Flagging too many normal transactions annoy customers. Low precision is bad. So you choose trade-offs. Threshold is a business decision. The models gives you probabilities, but your decision uses a threshold. If probability is greater than 0.6, flag it. That threshold depends on cost. This is why you must learn to talk in cost terms. Now the 2026 edition here is explainability and governance. In the real environments, a model is often reviewed, audited and monitored. This is why regulator emphasize model risk management, meaning model risk management as a discipline. In simple word, model risk management means know what models you have, know how they were built, validate them, monitor them, and have accountability. We will come back to this with a practical checklist, but first we need time series because finance data is time based. In time series, the biggest difference between finance and normal data science. Time series means data ordered in time. In finances, price data is a time series. Transaction sequence is a time series. Customer behavior over months is a time series. This changes validation. The core rule here, never shuffle time series randomly. In normal classification tasks, people shuffle and do random trend test split. In finance, that often creates a leakage because the future leaks into past. So you must do trend on past, test on future. This is sometimes called walk forward validation. Now let's understand the stationarity, what it means practically. Stationarity means the data behavior does not change too much over time. In finance, stationarity often fails. Market changes, customer behavior changes, regulations changes. So model must be monitored. Autocorrelation. Yesterday influences on today. Returns can show weak autocorrelation, but volatility often clusters. High volatility periods followed by high volatility. This is why forecasting volatility can sometimes work better than forecasting returns. Feature engineering for the time series. Now, in while you are preparing for tech type of questions, usually they would ask what kind of features you would create while predicting this particular type of model. Now, in practice, you create lag features, last day return, last week average, last month volatility, rolling maximum drawdown. This is easy in Python and it makes your model much better. But remember, each feature must be computed using only information available at that time. This is where fresher creates accidental leakage. Now, a retention portion. If you predict next month's default, can you use the next month utilization? No, that would be future. If you use utilization up to the prediction date, now we move to the risk matrix because risk is the heart of finance. Risk, evaluate risk, stress testing, and why model need governance. Let's talk risk in a way that makes you interview ready. Evaluate risk. Evaluate risk answers with X percentage of confidence. What is the maximum loss over y time horizon under the normal conditions? Example, one day 95% value at risk of a 1 million means over 95% of this loss should not exceed 1 million, but value at risk has limitations. It does not tell you how bad losses can be beyond the threshold. So many teams use expected shortfall, also called conditional value at risk. If we are in the worst 5% cases, what is the average loss? This is more informative for extreme risk cases. Stress testing and scenario analysis now. Stress testing is not a statistical trick, it is a business caution. What happens if rates jumps? What happens if liquidity dries? What happens if sector crashes? Even if your model says risk is low, a stress test can reveal fragility. This is why risk teams demand both model based measures and scenario based measures. Now, here's the MNC style reality. Risk models are reviewed and governed because if a model fails, it's not just a wrong number, it can be a financial loss, a compliance issue, and a reputational risk. That is why model risk frameworks exist. A major prudential regulators model risk management principles for banks emphasize taking a strategic approach to model risk applicable to model across the life cycle and relevant to internal models for regulatory capital calculations. Even if you are not in that exact jurisdiction, the mindset is spread globally: governance, documentation, validation, and monitoring. So now let's translate that into fresher friendly checklists. The model risk management checklist every fresher should know. If you say these points in an interview, you will sound like an professional. Here's the checklist. First, model inventory. List models that you use and what decisions they affect. Data lineage. Where does this data come from and how it is clean and who owns it? Then assumptions. What assumption does the model make? Are they reasonable? Then validation. How did you test performance? Did you use correct time split? Did you test stability? Then explainability. Can you explain the key drivers? Can a non-technical stakeholder understand? Then document it. Do you have a written summary of objectives, data method, performance, limitations? Monitor it. Do you track drift and performance over time? Change management. If you retain and change features, how do you ensure it doesn't break into the production? This mindset is exactly what regulators in large institutions are pushing. Life cycle discipline, not one-time modeling. Now we add the 2026 reality, generative artificial intelligence. 2026 reality, generative artificial intelligence is everywhere, but MNCs wants reliability. Let's talk about the biggest shift. Generative artificial intelligence, especially LLMs. LLM means a model trained on massive text data that can generate text. In finance, large language models are used for summarizing documents, answering questions, extracting key information, drafting content, and supporting analysts. But here is the one problem: hallucination. Hallucination means generating confident text that is not grounded in real data. In finance, hallucination is dangerous. So in 2026, the employable skill is not I used a chatbot. The employable skill is I built a reliable system that answers using verified sources and I evaluated it. That leads to a core architectures, which is retrieval augmented generation. It means retrieve relevant documents from your trusted knowledge base, then generate answers grounded in these documents. It reduces hallucination because the model has evidence. But here's the important part, and that is where most people are weak. Evaluation of retrieval augmented generation is hard. Academic surveys emphasize that evaluating RAG is uniquely challenging because it's a hybrid system, retrieval plus generation, and it depends on dynamic knowledge sources. So MNCs now look for people who can evaluate retrieval quality, answer quality, factuality, safety, and efficiency. You do not have to be a researcher, but you must understand the evaluation mindset. Let's make it practical. Build a simple retrieval augmented generation project right away. Imagine you want to build a finance policy question answering assistant for internal use. You have policy documents, annual reports, guidelines, and internal knowledge base. The naive approach: upload documents, ask questions, trust answer that will fail. The professional approach would be create a test set of questions and correct answers. Evaluate retrieval. Did you pull the correct paragraph? Evaluate answer. Is it correct and grounded? Track failure cases, hallucination, missing context, outdated info. Eight safeguards. If not found, say I don't know. This is how you sound job ready in 2026. Now, at the governance layer, in many regions, AI risk management guidance emphasizes identifying and mitigating technical risks of AI systems, especially when personal data is involved. And major regulations like European Union Artificial Intelligence Act, often called the Artificial Intelligence Act, define artificial intelligence system and create compliance expectation for high risk usage. You do not need to become a lawyer, but you must adopt the mindset. Data privacy plus risk controls are part of analytics in 2026. So, practical prompt to learn faster and work better in 2026. So, while you are working, this will help you directly. And also, while you are preparing, how to create a simple prompts. If you use an AI assistance for learning and drafting, do not use work prompts like explain regression. Use structured prompts. Here are fresher friendly prompts you can copy paste directly. First, learn a concept with job focus. Now, explain logistic regression in simple words for credit risk. Give one real world example dataset, common mistakes, and five interview questions with ideal answers. Second prompt, turn a finance problem into a modeling plan. I have a transaction data and customer profile data. My decision is loan approval, suggest target definition, feature ideas, leakage risk, and validation strategy using time split. Prompt 3, build a project story for resume. Here's my project credit default prediction. Write a resume bullet story using action method impact format. Also create 60-second interview pitch. Then improve clarity and documentation. Here is my model summary. Rewrite for non-technical manager in 150 words, highlighting decision risks and limitations. Then debug thinking. My model performance dropped in production. Suggest 10 plausible reasons grouped into data drift, concept drift, pipeline bugs, and business process changes. These prompts build the exact habits MNCs like: structured thinking, validation, documentation, and communication. Now we shift to the most important part for you as a fresher. What should you learn? What should you build? And how do you show it? The 2026 is skill map for finance fresher without listing a million tools. Now, I will keep this a simple and job focused. Skill first, finance intuition. You already have this advantage if you are in the finance background. Return risk, compounding, interest rate, basic accounting logics, revenues, expenses, etc. But you must connect it to the data. So, skill layer 2, Python plus structured query language, SQL. Python for analysis and modeling. Structured query language for extracting and joining data. You don't need 10 frameworks, you need fundamentals like real data, clean data, join data, group and aggregate, create features, build models, and evaluate correctly. Then statistics and probability, distribution, confidence intervals, hypothesis test, bias, and variance. Then modeling, regression, classification, time series, interpretation, calibration, and stability. Skill layer 5, model lifecycle discipline. Document, validate, monitor. This is where many freshers fail and MNCs filter hard. Skill layer 6, responsible AI basics. Privacy, risk management, evaluation, especially for generative AI. This is the strongly reflected in modern guidance about risk management of artificial intelligence systems. Now let's turn this into something you can actually do. Projects. 3 projects that makes finance freshers employable in MNCs. I'm not going to give you 20 projects. I will give you 3 that cover everything, and I will tell you exactly what to include so it looks professional. Project 1, credit risk scorecard, which is classification problem. Goal is to predict default probability. What to include here? Clear decisions of approve, reject, or review. Target definition with time window, feature engineering with point in time logic, handling class imbalance, metrics beyond accuracy like precision, recall, ROC, AUC, calibration, business threshold discussions, limitations, and monitoring plan. Your final output would be a notebook, Python notebook basically, with clean sections, a one-page summary explaining the model for manager, a simple monitoring plan, what metrics you would track monthly. Then other project would be volatility or risk forecasting, which is time series problem. So goal is to forecast volatility or risk exposure. So what to include here? Return calculation, simple and log return, rolling volatility calculation, trend on past, test on future, compare baseline versus model, explain why forecasting return is hard but volatility show clustering, provide stress scenario explanations. Your final output would be Python notebook, a plot of actual versus predicted volatility, a written explanation of what when the model breaks. Then the final project here, the third one, document question answering with retrieval augmented generation. Goal is to answer questions from a set of finance documents reliably. What to include here? Create a knowledge base from documents, retrieval step, answer generation step, evaluation test set, I don't know behavior when source is missing, risk controls, avoid personal data, log outputs, track errors. Your final output, a Python notebook, a small demo, 10 questions, sources, retrieved answers, a short evaluation report. This project aligns with the modern reality that retrieval augmented generation needs careful evaluation because the retrieval and generation components can fail in different ways. Now let's talk about presentation because projects alone are not enough if you cannot sell them. How to present your project like an MNC candidate? When you talk about your project, don't start with I used Python and build a model. Start with I solved a decision problem. Here is the perfect structure: problem and decision, data and time frame, target definition, feature engineering, baseline model, main model, validation method, results with business meaning, risk limitations, and monitoring plan. This structure makes you sound employable. So now I will give you a 60-second pitch template you can use in interviews. Now, here is what I built. You can say in interview, a model to predict probability of default for loan applicants. The business decision was approve, reject, or manual review. I defined default as a missing payments within a fixed window and made sure all features were point in time, so there was no data leakage. I started with a baseline and then built a probability model, evaluated using time-based validation, and chose metrics like ROC, AUC, and calibration because accuracy was misleading due to class imbalance. Finally, I documented limitation, proposed a monitoring plan for drift, and suggested a threshold strategy based on cost trade-offs. That is exactly the kind of answer that makes interviewers think this person understands the real work. Now, end-to-end walkthrough here from raw finance data to decision-ready model. Let's simulate a realistic data set. You have a customer table, one row per customer, monthly statement table, many rows per customer, payment history table. Target is here, default in next 90 days. Here's your workflow. Step 1, define the prediction date. Pick an as of date. Example, we predict default as of the end of each month. Step 2, build feature using only past data for each customer at each month and utilization ratio up to date, number of missed payments in last 6 months, average spend in last 3 months. Trend feature is utilization increasing. Then step 3 would be split data by time. Train on earlier months, test on later months. No random shuffle. Step 4, baseline. Baseline might be predict default probability equals over all default rate or use one strong features like utilization threshold. Then step 5 would be the model. Fit logistic regression probability model, checks coefficient and reasonableness. Step 6, evaluate. Using ROC, AUC, also check precision and recall for operational thresholds, check calibration. Then step 7 would be explain to business. Explain top drivers like high utilization, increasing delinquency, recent missed payments. Then document and monitor it. Write what data was used, what assumptions exist, where it can fail, what drift signals to monitor. This is exactly the type of structured work described in professional role definitions. Identifying business problem, applying statistical techniques, and delivering written presentation and reports. Now let's cover one more fresher killer topic that decides shortlisting: leakage and validation. Leakage, the silent reason freshers get rejected. Leakage means you used future information. Leakage can be direct or indirect. Direct leakage example, using default occurred means it's we are talking about loan defaults, okay, credit defaults. Default occurred as a field as a feature, which is obviously wrong. Indirect leakage example, using total spend in next 3 months accidentally because of the incorrect aggregation window, or using current credit limit that was changed after the risk decision. Companies will test you on this. If you want to sound strong, say I enforced point in time features and used time based validation to avoid look ahead bias. Look ahead bias means using future information unknowingly. Now we have built the core. Let's add the last two elements MNCs love in 2026: communication and responsible AI. Communication is the most underrated skills that gets you hired. Most finance freshers think jobs are only technical, but in MNCs you work with product managers, risk managers, compliance, and senior leadership. So your success depends on explaining clearly. Here's the simple rule: if you cannot explain it in simple words, you don't understand it deeply. So practice explaining what does the model do, what decision does it support, what data does it use, what can go wrong, how do we monitor it. If you can answer this, you will stand out. And then responsible AI, why it matters even for freshers in finance. In 2026, there is a rising attention globally on AI risk, privacy, and governance, especially in finance because finance is high stakes. Some guidance explicitly focuses on protecting personal data, mitigating technical risk when developing, procuring, and deploying AI systems. So, even as a fresher, you should have basic awareness. Do not use customer personal data casually in generative AI tools. Mask or anonymize sensitive fields. Log and audit outputs if used internally. Build safe failure behavior. If unsure, don't answer. And if you build a retrieval augmented generation assistant, evaluation and safety must be part of the project because research highlights unique evaluation challenges and need to consider factual accuracy and safety. So now, if you recap all of this, what you should remember after this video. Let's summarize everything in one clean message. As a finance fresher, your advantage is domain knowledge. To become employable in quant finance and data science roles, your mission is to add Python plus structured query language data skills, probability and statistics like regression, classification, time series, correct validation and leakage control, documentation and communication, responsible AI basics, and one more modern project using RAG with evaluation. And remember, MNCs don't hire you for models, they hire you for decision ready thinking. A large global employer survey shows the world of job is changing fast. Through 2030, technology and other macro trends are reshaping skills, and upskilling is a constant requirement. So treat your learning like a job, but build a project, validate properly, document clearly, communicate like a professional. If you want, in the next video, I can do this one of these. Build the credit risk model project end to end in Python. Build the volatility forecasting project end to end in Python. Build a RAG assistant with evaluation in Python. Or I can show you how to present this project in a resume and in interviews. Write in the comments which one you want. I will create it. Thanks for watching this one. See you in the next one.